Welcome to Lesson 2D, Classification of Pollutants. We're going to discuss the various ways that EPA classifies air pollutants. We'll learn what these acronyms mean. We'll talk a little bit about a government regulation that really influenced air pollution in this country, the Clean Air Act of 1970. So let's learn about how EPA classifies air pollutants. There are several ways that we can classify air pollutants, and EPA is the official agency, environmental protection agency, that does this. The first way is primary and secondary air pollutants. What are primary air pollutants? They're pollutants that are emitted directly from the source, so they're directly put into the atmosphere. And I'll just give you a list of examples: carbon monoxide, nitrous oxide NO, SO2, sulfur dioxide, and then various VOCs, which we already talked about, volatile organic compounds. And let's just discuss briefly where they come from. CO comes mostly from burning or combustion, especially when it's non-ideal combustion, which is the real life. We get some CO. Nitrous oxide NO also comes from burning and combustion, and also from electrical discharge. Sulfur dioxide comes primarily from burning and combustion of coal primarily, and also from volcanic eruptions, so that's a natural process. We'll talk about that a little bit later. VOCs is mostly from evaporation. So you have liquids that evaporate, like we've already talked about. For example, paint, gasoline, etc. So those are primary. They go directly into the atmosphere. A secondary air pollutant is a pollutant that is not emitted directly from the source, but formed in the atmosphere by chemical reactions of primary sources. This can be a multiple step process. For example, NO, nitrous oxide, will combine in the atmosphere with some VOCs and form NO2 plus some other VOCs plus HNO2 plus O3. And let me label some of these things. So we're talking about nitrogen dioxide on the right, and nitrous acid and ozone. And on the left we have our primary pollutants, but they interact with each other and form all these other chemicals. So these are all secondary pollutants, whereas the NO and the VOCs in this case are primary pollutants. Now that doesn't mean that all these three chemicals plus other VOCs cannot also by themselves be primary air pollutants. It's just that in this particular chemical reaction, they are secondary air pollutants. So for example, ozone is a secondary pollutant in this case, but O3 is also a primary air pollutant. For example, copier machines give off ozone. There's a lot of work on some of the earlier copy machines. Also, any kind of corona wires with electrostatic precipitators and ionizers, etc., can give off ozone. So ozone can be a primary source, whereas here it is a secondary source. Another example is acid rain. We have SO2, so remember SO2 I had up here as a primary air pollutant. So that's our primary air pollutant. Interacts with oxygen in the atmosphere and forms 2SO3. So that's our chemical equation. And this is sulfur trioxide. So this is a secondary air pollutant, sulfur trioxide. Well, then what happens? I said this can be a two-step process, and this all happens at the same time. But SO3 will then react with water, raindrops, little raindrops, and produce H2SO4, which is sulfuric acid or acid rain, since this is actually an aqueous solution. So you have H2SO4 in these water droplets, and then they fall to the ground as acid rain. Now you could combine this chemical equation and just say 2SO2 plus 2H2O plus O2 yields 2H2SO4. And that would also be a proper chemical equation, but it really happens in two steps like I first wrote out. And EPA is concerned with both primary and secondary air pollutants, and we'll see later that some of their criteria have both of those in there. There's a second way that EPA classifies air pollutants, and these are natural versus anthropogenic. Natural would be anything that, as its name means, natural. It's not man-made. So volcanoes is a good example. Lightning produces ozone and other things that can also cause fires. So we have natural fires, decaying plants and animals, produce various chemicals that come off of them, and they also smell pretty bad when they're decaying, etc. So you can think of lots of natural air pollutants, so not associated with human activity. Anthropogenic, processes associated with human activity. So these examples would be power plants and other activities of humans. You can think of a lot of other anthropogenic air pollutants like automobile exhaust, chemical production, refineries, agriculture, construction. These all are man-made or human activity-related air pollutants. There's yet a third way that EPA classifies air pollutants, and these are what's called criteria air pollutants, or CAPS, C-A-P-S, CAPS, pollutants for which there are NAAQS, which are National Ambient Air Quality Standards. Now, originally there were 7 of these back in 1970 when they started worrying about air pollution and doing something about it. There are 7 original CAPS, and you should memorize these CAPS, and they are carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, lead down at the bottom, and then 2 kinds of particulate matter, PM, and these are PM 2.5 and PM 10, which is based on the size of these particles. If they're less than 2.5 microns, they're PM 2.5, and less than 10 microns are PM 10. The PM 2.5 are also called fine particles, and the PM 10 are called coarse particles. Now, if you just look up criteria air pollutants, sometimes you'll see 6 listed, sometimes you'll see only 5 listed. So what happens is sometimes they don't include lead. It was one of the original 7 CAPS, but we have greatly reduced the lead in the atmosphere. When I was a kid, I remember buying either leaded or unleaded gas, and you could buy leaded gasoline that they would put lead into gasoline to make it perform better and prevent knocking and that kind of thing. They also had lead in paint. Those have both been removed. Now we only have unleaded gas, and we don't put lead in paint anymore. They found out that lead was very hazardous, but the lead in the air has been reduced so much that it's sometimes not even on the list. So these are the 7 original CAPS. Also, sometimes they combine these into just particulate matter. So you might see all of those put together as one criteria. So I want you to remember the 7 original ones. By the way, lead and acid rain that we mentioned up here were big things when I was a kid, much like global warming, say, would be today in ozone, the ozone hole. We'll talk a little bit about ozone later. There's also something called HAPS, or hazardous air pollutants. These are just chemicals that are considered to be hazardous to your health, may cause cancer or other serious health effects. If you go to the EPA's website, and I give you the link there, this is just the first few, the first 4 there actually, and they're alphabetical. You can find all of them. Now, there were originally 189. They've added a couple, they've removed a couple since then. So right now, last time I checked, there are 187. That hasn't changed for the last couple years. One interesting tidbit, lead is the only CAP that is also a HAP. If you look up on this list and you look up carbon monoxide, SO2, nitrogen dioxide, etc., you're not going to find them on this list. So even though they are hazardous air pollutants, EPA considered them to be already mentioned, I guess, in the CAPS. So it's kind of strange. Since they're part of the CAPS, they're not HAPS, but yet lead is. So I don't understand why, but that's just how it is. And these are occasionally updated, etc. Now let's talk a little bit about the Clean Air Act. 1970 was a huge year for air pollution. People realized that we were starting to get some bad air, breathing, causing lots of cancer, lots of other diseases and lung diseases. So there was legislation in 1970 that established the NAAQS, the National Ambient Air Quality Standards, for each of the CAPS. Remember, what is a CAP? It is the air pollutant for which, up here, National Ambient Air Quality Standards exist. So when we go to this page, we're saying that we established the NAAQS for each of the CAPS. So that's consistent. That's what EPA did. The legislature did it, but it was part of EPA to monitor this. And EPA got powerful back in 1970 to do this. So what does it do? It sets standards, and we basically can think of this as maximum concentrations for healthy air. In other words, these are the actual NAAQS. Also, it sets criteria in order to pick the CAPS in the first place. I'll just write out these criteria for you. The criteria are that they're anticipated to endanger public health or welfare. So in other words, they're either bad for your health or they're bad for the infrastructure like visibility, agriculture, etc. And they're numerous and diverse. In other words, ubiquitous, they're everywhere. Mobile, like automobiles, or stationary, like power plants, that they're producing a lot of air pollution. So take carbon monoxide, for example, is produced by cars and by power plants. So there's a lot of CO that's put into the air. So it was one of the caps. Lead used to be in the air a lot from automobiles, but now it's not. Primary standards. So now there's another primary and secondary. So don't confuse these with what I called primary and secondary air pollutants previously. We're talking about the standards here, these NAAQS standards. There's primary standards, which means standards to protect the health of the sensitive populations. Sensitive populations are elderly, children, and then people with asthma. So we call that asthmatics and other respiratory diseases. So they set these pretty low, these NAAQS standards, so that even elderly children and people with asthma can tolerate that air. So if they can tolerate, healthy people, like most of you are, would certainly be able to tolerate it. And then there's secondary standards, which protect the public welfare. So I had briefly mentioned these. I'll now write some of them out, like visibility. I teach a whole course on visibility of air pollutants and opacity. So in other words, you can see it, it can block views. So you go to the Grand Canyon, if there was a lot of air pollution there, you might not be able to see the other side. So visibility is one of the important things. Also damage to other things like animals. So it's not just human beings that we're worried about. Vegetation and crops, in particular, crops that are useful vegetation, buildings. Acid in the air can cause paint damage and rust, etc. So again, we use the same words primary and secondary, but these are based on the standards. The former primary and secondary was primary, meaning produced directly into the atmosphere, emitted into the atmosphere, whereas secondary was due to chemical reactions after those primary air pollutants were introduced. Now you can go to EPA and type in NAAQS and you'll come up with this table. I just have the caption there, and then here's the actual table of NAAQS that was downloaded January 11th, 2021, and this has not changed for a couple of years, as I said. So when we talk about the NAAQS, what we're talking about are National Ambient Air Quality Standards for the CAPS. So there's our CAPS: carbon monoxide, lead, nitrogen dioxide, and now we have primary and secondary, which I just defined up here, for how we set these standards. So primary, again, worried about health of people. Secondary, health of animals, damage to buildings and vegetation, etc. Let's just take one of these here, carbon monoxide, a primary standard. There's no secondary listed. And then often they'll have 1, 2, or 3 different ones. 8 hours, 9 ppm of CO is considered safe, and 35 ppm for 1 hour is considered safe. And then it also gives some notes like no more than once per year. And you do the same thing with lead and nitrogen dioxide. Here we have a primary and secondary standard for either an hour, short term, or a year, long term. So obviously for short term, like here, short term is bigger concentration than long term. The EPA is saying that you can tolerate 53 parts per billion, now that's pretty small, of NO2 continuously for a year, or 100 ppb for 1 hour. And they give some comments about 98th percentile and annual mean, etc. And we do this for all the CAPS, ozone, and then particle pollution, PM. They split it up into 2.5 and PM10. And you can see these are now mass concentrations, so primary and secondary, and sometimes one is bigger than the other. Like here, primary, meaning we're protecting people's health, 12 microgram per cubic meters is considered safe for elderly, infants, asthmatics. Secondary, and again, these are averaged over 3 years, so these can change very slowly, but 15, it's a little bit higher one for secondary air pollutant. And then they have a third one here for short term, 1 day. This is the one that's often exceeded, that you'll find in reports. Sometimes you'll hear that the air in a certain city, maybe Los Angeles, and oftentimes in China and India, you'll hear about the criteria being exceeded for PM2.5. These particles can go real deep into the lungs. And the same kind of thing for PM10. And then finally, sulfur dioxide. These are very small, 75 ppb for primary, 0.5 ppm, which would be 500 ppb for secondary. So the primary is usually much smaller than the secondary. For obvious reasons, we're worried most about human health. Finally, I want to look at some trends since the Clean Air Act of 1970. How are we doing with our air pollution? I downloaded this plot from the EPA. These curves are CAPS concentration minus the NAAQS concentration divided by the NAAQS concentration times 100% for each pollutant. And you can see all the pollutants that they're plotting in the legend down here. You can see that these are our CAPS, but they have two different measurements of some of them. This horizontal line at 0% would indicate that the actual concentration is the same as the NAAQS, so the numerator would be 0. This plot only goes from 1990. By that time, most of these pollutants were already below the NAAQS limit, but a couple of them, SO2 and PM2.5, were above the NAAQS in 1990. In fact, they didn't fall down below the NAAQS until about 2008 or so. This green one, PM2.5, has lingered around the NAAQS since then, but SO2 has continued to go down as we're burning cleaner coal and as a lot of the coal plants have gone offline as we switch to more green energy. But overall, you can see a clear trend downward, so our air is improving during this period of 3 decades or more. So that's a good sign. Here's another plot I copied from EPA. This compares emissions to several other benchmarks, such as gross domestic product, which from 1980 has gone up almost 200%. Vehicle miles traveled has gone up about 100%, and population has increased 46%. Meanwhile, our energy consumption has grown only 25% since 1980 and has stayed fairly flat since about 2010. Carbon dioxide emissions peaked here in about 2007, but have gone down steadily since then. Now, these are all compared to this purple one, which is aggregate emissions, 6 common pollutants. These are our CAPS, but there's only 6 since they usually lump together the 2 PMs, the PM2.5 and the PM10. So again, in terms of total emissions, we're actually decreasing 73% over 4 decades, even though the population has increased significantly and we're traveling more. Also notice the sudden drop in 2020 for vehicle miles and gross domestic product and energy consumption. You can guess what that's due to: COVID. So overall, combining this plot and this plot, we can see that we're doing a pretty good job in our country with air pollution. Thank you for watching this video. Please subscribe to my YouTube channel for more videos.